Okay guys, so the way that we're going to solve these systems is by one of three methods. We have elimination, substitution, um, or graphing. Okay, so most of these we're going to do by a substitution or elimination. So for example, number one, it's ready for substitution, meaning this is ready to be substituted for y, because it's y is all this. So I'm going to substitute that whole equation for y with parentheses. So, sorry, let me focus here. Then I'll do 4x minus 12x minus 30 equals 2. Negative 8x equals 32 by adding 30. X equals negative 4. So that's half my solution is negative 4. Ooh, it's blurry. Okay, so then what I would do is take negative 4 and plug it anywhere for x and find y. Well, this is the easiest place. So 2 times negative 4, y equals 2 times negative 4 plus 5. So that's negative 8 plus 5 is negative 3. And that's substitution. So if we look at number 2, number 2 is almost ready for substitution. It's really close. I would need to add 4x, making this equation 4x minus 3. So now it's ready for substitution. So I would take that whole equation with parentheses and put it in place of y. So then I get negative 9x plus 12x minus 9 equals 3. Negative 3x, I would add 9 over. It's 12, x equals negative 4. Kind of funny. And then I would take negative 4 and plug it here. 4 times negative 4 minus 3, that's negative 16. Minus 3 is negative 19. It's always good to check back over your work too, because on these systems, we're going to get really big and complicated with them. Today is really simple, but these little mistakes you might make can really, really, really hurt you when it comes to solving these problems. So let's see. How about one like number 3? Number 3, I would honestly get x by itself right here. So x equals negative 3y plus 15. I could take all this and substitute it for x, so negative 3 times negative 3y plus 15 minus y equals 3, 9y minus 45. So then that's 8y equals 48, and then y equals 6. So just to kind of refresh your memory, when we're solving these systems, it's where these two lines are intersecting, so it's a point. And so we always write them as a point. And then to find the y, I just take somewhere, so I'm going to plug it in right here and place it this y right here. So it's going to be negative 3 times 6 plus 15. Negative 18 plus 15 is a negative 3. So why don't we try a elimination-like problem. So looking at number 5, it's set up for elimination because everything's lined up, meaning the x's are in a row, y's are in a row, equal to signs are in a row. And then it's also known as it's in standard form. So standard form. When I add these two equations together, your x's cancel. So then I would finish solving this. Okay, so I already have one part of my solution. Y is negative 4. So it doesn't matter where I plug it in. Say I pick the second one, negative 6x plus 3 times negative 4 equals negative 12. Negative 6x minus 12 equals negative 12. Negative 6x equals 0. X can be 0. Don't freak out when x is 0. X can be 0. Sorry, there's my work. Okay, so let's look at, say, number 6. Number 6 is all set up for elimination, except for we can't eliminate anything. So what we're going to have to do is we're going to have to multiply an equation by a number in order to get them to cancel. If you notice that the x's are awful close, if this was just a negative 10, then it would work. So I'm going to multiply this entire equation by negative 2, and I'm actually going to put it down here. So when you do this, make sure that they all get multiplied by negative 2. So that's negative 10x plus 6y equals, I'm going to have to do that real quick, negative 58. Hope so. Okay, so now, what I have now is my result is these two equations, so those do cancel. 4y equals, let's see, what is that? Not very good. It's a 16. So y equals 4. Now, it doesn't matter where you plug this in at. You can plug it into your new equation. You can plug it into your old equations. Either way, it should work. So that, right, plug it in here. 5x minus, so I plugged it right here. 5x minus 12 equals 29. Add 12. Got a little funky answer here. 41 over 5? Seems really funky. Let me double check my work. I feel like I got a sign wrong. Oh, okay, so very important lesson here. See this little negative? Well, that should have been negative 16, which means this should have been negative 4. Negative 4. Well, then what happens over here? See how one little sign, okay, that's positive. So then I'm going to have to subtract 12. 5x equals 17. It's still a funky answer, but it's the right funky answer. Let this be your lesson. So, let's look at number 4. Okay. So, number 4, we could really do any method we want. I'm going to do elimination. It's probably one of my more favorite ways. So I'm going to multiply this equation by negative 4 because what I want is these x's look awful close to canceling if just one was a negative 8 and this is a positive 8. So I'm going to put the result up here, negative 8x plus 4y equals negative 16. All right, so that went away. So that became up here. So then what I have left, my x's cancel. My y's cancel. So on this side I have 0. I have literally nothing, but there is a number. Okay, and over here I actually have 0 also. So you have to ask yourself, is this true or false? Of course it is true. Well, what you have here on the graph is you have the same line lying right on top of itself. So the question is, how many times would it be intersecting if it's laying right on top of itself? We would have infinitely many solutions. Not one solution, but infinitely. You can even use the little symbol here if you wanted to. So the question is, what do you answer when it's false? Well, let's jump down to the bottom of the page, okay? Let's line out our 3 scenarios, right? Okay, scenario 1. They intersect. We have 1 point as a solution. Scenario 2. It's the same line, right, lying right on top of itself. that means it's exactly the same. Okay, it would mean that you have infinitely many solutions. And then scenario 3 would mean you have two lines that are parallel, meaning no solution. Right? No solution. Okay, let's do our last one. Let's do by graphing. So, for instance, on number 9, I'm going to make sure that to get y by itself, so I'm going to subtract 5x. So 2y equals negative 5x plus 16. Divide by 2. Y equals negative 5 over 2x plus 8. And then this one's already ready to go. So I'm going to start with the negative 5 over 2x plus 8. So go up to positive 8 on the y-axis. 1, 2. Down 5. 1, 2, 3, 4. Right, 2, down. You want to do as many points as possible because we don't know where they're going to intersect. Okay, so then I'll do the other one is at positive 3. Has negative 5 over 3 slope. 1, 2, 3. We can see right here, because we did a good job graphing, we can see where they intersect. They intersect at 6, negative 7. Sorry, my 6 is kind of funky. I think that's all of them. I know I left the last 2 blank, but you can work those 2 and get your solution. So please, please, please come ready tomorrow, ready to solve these systems by hand. No calculators.